So my name is Jean-Philippe Faure. I'm a CEO at Progilon. I'm the chair of a Nessum Technical Working Group. And today I will quickly draw the big picture of standardization of Nessum technology, in particular with IEEE 1901. So the 1901 is a kind of long story. It started years ago with the approval of IEEE 1901. It was the base standard, developing wavelet, so low power consumption and robustness. Then we developed an amendment, 1901A, to increase the distance and the speed, or either or. And we introduced the flexible channels, and I will explain quickly. Then we had another amendment, 1901B, with we added authentication, in particular compliance with 822.1x, so increased security. And the latest amendment is 1901C, where we added clock synchronization and enhancement of some channel operation, and we expanded the scope of 1901 to PLC, beyond PLC, not only PLC, but of the media as well. So let's go to the flexible channel amendment. So it looks like that we have 15 selectable channels in the technology. They are based on the wavelet. And so you see the width of the channel depends. So sometimes we have big channels covering a wide spectrum of frequencies, and we provide high speed. This is what we have, one channel at 1 gigabit per second, which is at the bottom X12. Or we have smaller channels for long distance. We have 4 channels at 60 megabit per second, X4 to X7 for long distance. And so it's really flexible. You can choose, and I will explain how we achieve longer distance and longer speed. So, yeah. So distance can be increased by basically when we reduce the channel width, we focus the energy on a small part of the spectrum, and this is the way we actually increase the speed, the distance. Sorry. So you see the blue line. It is the standard channel. So you see that the speed decrease with the distance, and so basically up to 400 meters, we have 5 megabits per second. But when we reduce the channel width, and if we do by 4, this is a green dotted line, then you see that, of course, the maximum speed is reduced, but the distance is increased because we can still have 5 megabits per second of over 1,000 meters. Also, the flexibility provides the feature to select in which part of the spectrum you can transmit. And this is a good feature to select quiet bands. So when you have noise, for example, you can select to not transmit in the band where there is a noise, and you can choose a band where there's less noise to get a better performance. So this is all the flexibility we provided in 1901A. Next one is authentication. So for those who are familiar with 822.1x, so this is how it works. We have a supplicant, we have an authentication server, and we exchange information using Radius and to authenticate the devices before they join the network. So it's really a demand for smart gate application to provide security to avoid some devices not authorized to join the network. Then the latest amendment is 1901C, and it's basically, as I explained before, we expand to any media. So it's not only a power line, AC or DC or coax cable, signal cable, but also we included optical fiber and communication using light, visible or infrared, but using light, and radio wave as well. So we have an option to go to very short distance radio wave, high speed. In some use cases, it's very convenient. We support also the IEEE 1588 precision time protocol. So it's PTP version 2.1. So this is important for application in industrial application like smart manufacturing. And we introduced 2 new channels in very low frequency from DC to 15 megahertz. So it's really a small bandwidth. On top of this, we had another layer, which is called multi-op. It is a layer 2 routing protocol, and it's defined in ITU. And multi-op provide a feature to extend the range. So you see, it's like a tree and a tree networking, where we have so you can reach the different node not in a single op, but up to 10 ops to reach nodes. And we increase the number of nodes also supported in the network, because we can support a very large network with 1024 nodes into one single networks. And my final slide is about certification. So previous slide was about standardization, and certification is basically provided by Nessum Alliance. So certification provides interoperability and performance check. So we have a connective verification test and test performed with a golden device. And we have 2 test labs that are authorized by Nessum Alliance. One is the Panasonic test house, and the second one is UL test house in Taiwan. Okay, thank you for listening to this presentation.